Okay, now I'm going to solve a question, AP question from 1995, the first E and M question, but part D. And so we have this cylinder which has a charge density throughout. So this is an insulated material, but this is equal to this rho naught, which is a constant, R, which is the distance, the radius of this, over A, which is this set radius for the cylinder, to the 1/2. And they're looking for E as a function of R, where R is less than A. So I will just take Gauss's law. So we have EA is equal to Q over epsilon naught. So my Q, let's pick on my Q. My Q is what I'm going to actually need to try to find to plug in here, is going to be the integral of this rho dV. Well, let's figure out what this dV is. dV is then going to be equal to my 2 pi r, so I'm taking these little circles in here, multiplied by L, because I am dealing with this cylinder. This isn't a sphere. Multiplied by dr, so all of these little cylinders that are added up. And so then if I break this down, this dV down further, well actually I'm plugging this dV back in over here, so then I end up with Q is then equal to the integral, now I'm plugging in for rho naught R over A to the 1/2. Now I have my dV 2 pi r L dr. Now I'm going to pull out all my constants. I end up with Q is then, I can pull my rho out, rho naught. This is then going to multiply by 2 pi L, and I will also pull out the square root of A here. That's going to remain a constant, and then the rest is this R to the 1/2 multiplied by R, ends up being R to the 3/2 dr. That's from 0 to R, wherever I'm looking at. So then I end up with Q is then equal to this rho naught 2 pi L over the square root of A. We end up taking the integral of this, you end up with 2/5 R to the 5/2 as we evaluate it from 0 to this R. Now I'm going to take this, I'm going to plug it in, recognizing that this A right here is 2 pi r L, but that's the Gaussian surface that is at a specific R, which is different than the R that we are using to figure out what the total Q is within this sphere at a distance R. So now I'm going to put all this together. I end up with E A is going to be my 2 pi r L is equal to, now that I've evaluated from 0 to R, this R is the same as this R. So then we end up with rho naught. We end up with now 4 pi L over 5 square root of A R to the 5/2. Now we get to cancel out some stuff. We can cancel out a pi, we can cancel out L, we can cancel out a 2 and a 4, so that's the 2 gets carried up there. Then we have this R here, so we're canceling out this R, and we end up with this going to 3. So my E is then equal to this 2 rho naught over 5. Oh, I forgot my epsilon. My epsilon here had to get carried down. That would be the epsilon right here, pulled in front of this Q. So then I end up with epsilon naught square root of A R to the 3/2. And that is my answer for part D.